And
yes, it has come. Thank you.
Can you see that?
Yes, clearly.
Good, thank you. So, konnichiwa. I'm happy to be part of the meeting. I'm sorry I'm not with you in Japan, but I hope that you are all safe, as we are here in Europe, but we're safe, but we are worried. So I've been invited to talk, and I'm not going to say very much about FRAM as such. You have heard other examples, other talks about FRAM and how FRAM can be used. I will refer to FRAM indirectly, but I will be talking about something else, which I have indicated by the title here. The issues are control, requisite variety, and systemic potentials management. So let me begin. To me, and I think to everybody else, a major issue is being in control of situations. This is being in control of your personal life, being in control at work, being in control of companies, being in control of a space mission, being in control of the Omicron variant, and being in control of the economy or whatever. So the big concern is being in control, and we know that there are sort of two different situations. One is being out of control, which we don't want to happen, and one is being in control, which of course is what we would like to happen. And we know that we are out of control if we are uncertain about what has happened, if we do not understand what has happened, if we do not understand what happens now, or if we do not understand what is going to happen. And very often, this is the case. When this happens, we are also uncertain about what to do, or we are unable to do what we would like to do. And so when we're out of control, nothing goes as it is planned, and we have many unexpected events. The opposite, of course, is being in control, and being in control means that you understand what has happened, you understand the past developments, you understand what happens now, and you feel reasonably sure about what is going to happen in the future. You're also in control if you're able to do what you plan to do, and if you have the means, the resources, and the time to do it. And when we are in control, things go as they should, and there are few surprises. So of course we want to be in control, and I think the previous presentation by David Slater shows how the Formula One teams try to be in control of the situation that they're facing. This discussion of control is of course not new, and one of the very important parts of control is called the Law of Requisite Variety. It was proposed in 1956, a long time ago, by this man here, Rosh Ashby, one of the leading cyberneticians and one of the great developers of cybernetics. And what the Law of Requisite Variety says is that the variety of the outcomes of the system, what can happen in the system, can only be decreased or reduced by increasing the variety of the regulator of the system. And it's written like this: the VO is the variety of the outcome. The VD is the variety of the dynamic system. And the VR is a variety of the regulator. And it basically says if you want to minimize the variety of the outcome, and this is what we want to do if we want to be in control, we want to minimize the variety of the outcome, then the variety of the regulator must be as large as possible and at least as large as the variety of the dynamic system. Or another way of saying it is that a control system must have as many possible states as the system it is supposed to control. Nothing strange in this, and one way of showing it is this is the possible events that can happen in the environment, and these are the possible or the prepared responses that the control system has. And you can see if A happens, the control system can respond. If B happens, it can also respond. But if E happens, it cannot respond because it has prepared another response. So it will lose control. So the interesting thing is, how can we ensure that the control system has sufficient control, sufficient variety to control the environment? And it turns out that there are three different solutions to that, three principally different solutions to that. The ideographic solution, the incremental solution, and the nomothetic solution. So I'll explain what I mean by these strange terms. The ideographic solution is one that we know very well. It basically says, try to imagine anything that could happen and prepare for that. Think what could happen and describe in details how the responses should be. So think about particular events, particular scenarios, and specify how they can be detected and what you should do in response. So this is what we do in classical safety analysis and classical risk assessment. You try to assess the risks. You try to find all the possible situations where something could go wrong, and you try to think out replies or responses from the system ahead of time so that nothing surprising is going to happen. So this is a classical way that we deal with control. We try to control things by thinking of everything that could happen and prepare for that. In the terms of resilience engineering, it means that we assume that how we think about things, work as imagined, is complete and correct, and that work as done corresponds to work as imagined. And what we sometimes do is we constrain work as done to make sure that it corresponds to work as we have imagined it. A simple example is this, taken from healthcare. This is actually not about the work that the clinical staff does, doctors and nurses, but this is the work that the inspectors do, the people who do the surveys, who do the accreditation of the clinical work. And if you look at that, it turns out that the guidelines for accreditation of hospitals contain 1,164 regulations and guidelines, and they fill 457 pages. So this is work as imagined. This is what you think that the people who make the surveys actually do. And I think in practice, we must expect that they do not do that. Nobody can follow 1,000 164 regulations and guidelines. They find other ways of doing it. But by having these guidelines, you say, we have controlled everything that could happen, and we feel certain we will never be out of control. I mentioned work as imagined and the work as done. So here is a FRAM example of what that looks like. This is a traditional example of work as imagined, perform an X-ray, provide sedation, reduce fracture. So it's treating a fracture again. And this is a procedure, just these 6 steps. And this is a FRAM analysis of the same kind of work. And not surprisingly, the work as done described by FRAM is quite different from the work as imagined. So it means that the idiographic solution to control doesn't actually work very well in practice, because real life is too complicated, it's too complex, it's too variable. So the second solution is what I call the incremental solution. And that basically means that whenever something happens that had not been expected, we just add another rule. We add another type of control, we add another response to the system. And there will always be unexpected things that happen. We have from many years ago, the famous Murphy's Law, which says, if anything can go wrong, it will. And we know this is absolutely true. So whenever we have that, we have all the restrictions, the limitations, but even if something happens that wasn't expected, we just add to it. New laws, new rules, new regulations, and new compliance. And what it means is, first of all, that the response to what happens is always lacking. So control is always lacking behind. There will always be unexpected situations. And also that the number of specific idiographic responses will be very, very large, which means that people will try to generalize to make inefficiency fairness trade-off, which in fact limits the effectiveness of the control. And as an example of that, also again from the medical world, is the guidelines for emergency surgery of a fractured neck or femur. So this is the problem. There's a fracture here in the neck of the femur, and a study 10 years ago found that there are about 75 clinical guidelines and policies for this. And of course, when they started writing this, they didn't start to write 75 guidelines. They started by one, I assume, but experience showed it wasn't enough. So they increased and increased and increased, and you end up with this mess of guidelines that nobody can actually work with. So the idiographic solution and the incremental solution are not very good solutions. So what's the third option? It's what we call the nomothetic solution. And the nomothetic solution says, well, instead of trying to think of specific cases or events and specific responses, try to think of the general or the generic capabilities that a control system must have in order to be able to control a process or a system or an organization or an activity. So it says, forget about looking at specifics, because it will never be possible to think of all the specifics. Try to think in more general terms. And this is precisely what resilience engineering and resilient healthcare have been doing. And resilience engineering has proposed 4 nomothetic potentials, namely the potentials to respond, to monitor, to learn, and to anticipate. And when we started this, we called them the resilience potentials, or resilience abilities, or cornerstones, and so on. But now we realize that this is not peculiar to resilience, but has a generic value. So we call them the systemic potentials. But it refers to the definition of resilience, or rather the definition of resilient performance. Resilient performance is defined like this: that an organization is able to function as required under expected and unexpected conditions alike. And the unexpected conditions are changes, are disturbances, but are also opportunities. And the sort of the theory and the practice behind this says that we need, in order to do that, you need to be able to respond when something happens, both to threats and to opportunities. You need to be able to monitor what happens, both externally and internally, both in the system and in the environment. You need to be able to learn from what happens, both learning from what goes well and from what doesn't go well. And you need to be able to anticipate. You need to anticipate what will the consequences of the responses be, but also anticipate what may happen in the surroundings, in the externals of the system in the future. And I think the pandemic is a wonderful example of that, because everyone, individual persons like you and me, and governments and the WHO, try to anticipate what is going to happen. What is going to happen, for instance, to travel restrictions in 2022? What is going to happen to the economy, and so on. So we need a system to be able to be in control of what you are doing, what you are dealing with. You need these four potentials, and it's easy to explain, easy to argue for them, because if you're unable to respond, then you will lose control, because you will not know what to do for a specific situation. If we are unable to respond to the Omicron variant, we seem to be able to, but there may be a new variant of the COVID-19, and initially we'll be unable to respond, and we will lose control. If we are unable to monitor what happens, then we'll be surprised. That's why a lot of effort are spent on testing now. Certainly in Denmark, we are being tested almost continuously, because we need to know what the situation is. We need to be able to learn. We need to be able to learn from what went well, so we can do that again and do it better in the future. And we also need to be able to learn from what doesn't work, so we don't do it in the future. And we need to be able to anticipate, to look ahead, to think about the future. So this has been developed into a methodology. I'm not going to go into the details of that, but basically saying that what we do have are a set of performance potentials. We have sets of questions that can be developed and asked and used to get a measurement or an indication of how well the potentials work at the moment. I will give you the reference to the document describing this methodology at the end of the presentation. But there is a methodology called the systemic potentials management, or systemic potentials monitoring. And the nice thing about that is that you can use it to ask about how others do their work when you are managing a group of people, or managing a production, or managing an activity. And this is what you normally do. But you can also use it to ask yourself, how well are we doing our work? Because that is just as important. In fact, You have to be in control of what you do, just as others have to be in control of what they do. And the questions in the SPM can be used on all levels of an organization or a system. We can use the responses we get in many ways, but one way of using the responses is to show a profile. This is a profile for responding, and this radar diagram shows that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different questions. And these are the answers to the 10 questions at one time, 1 to 4. And these are the answers to the same questions 4 months later. And what the polygon shows is the difference in answers. And it's very easy to see from the graphical representation here how the answers have changed, how the answers here have improved, and how the answer here, for instance, has diminished. So again, this is described in a document. I'll give you the reference at the end. But one thing that's very important in all this, let me just go back. One thing that's important in this is that the 4 potentials can be understood as functions. The potential to respond means the function of being able to respond, the function of being able to monitor, the function of learning, and the function of anticipating. And when I say function and when I say FRAM, obviously the next point is to say, well, these functions are not independent of each other, which means that the 4 potentials are not independent of each other, which means that we can use FRAM to develop a model of the 4 potentials, which then also, in some sense, becomes a model of the organization. But it is also a model that is useful when you formulate the questions and when you think about how to use the answers you get to the questions, because the answers must be used to make interventions to change or control the state of the system. But because the functions are interdependent, you cannot simply respond to answers in isolation, but you have to consider how what you do with regard to one potential may affect what will happen in another potential. And this is a very simple overview model just to illustrate the point that they are interrelated. Here is a slightly more detailed model, and for a specific organization, you can build a specific model that actually represents that organization. So to conclude, to come back to what I started by mentioning, the law of requisite variety, I think this is a fundamental law. Maybe not everybody knows it as a law, but we all know it in practice, that in order to be able to manage or control a system or an activity or a process, we must be able to respond to everything that can happen. If we cannot respond to what happens, we will lose control. It is as simple as that. The formulation of the law is very useful because it shows that the traditional solution to control is to reduce the variety of the system, to limit what the system can do, to limit what people can do by establishing rules and guidelines and in insisting on compliance to the rules. Because if people comply to rules, then nothing can happen that hasn't been described by the rules. But we also know that this doesn't work in practice. And the logical alternative to that is to increase the variety of the regulator, increase the number of conditions and situations that you are able to respond to. And this can be done by using the idea of the systemic potentials. And the systemic potentials, as I said, are actually functions. Quite simply, they're functions, and as functions, they can be modeled with FRAM. And in this way, FRAM can begin to play a role in how we become better at managing systems, managing processes, managing operations. I mentioned that there is a report out on that. You can find the report here. I will leave the slide on for a while. I have also sent this my slides to the Motosan, so I'm sure you will get them after the meeting. So with this, thank you very much for your attention.